Hi, it's Gadget UK here again, back with a Sega Master System. There'll be a few videos following this because I've got two of these Model 1s. I've got Model 2. These kindly came from Martin. I'll show you the letter that he kindly sent me with these. But yeah, he threw the Model 2 in as a gesture, so that's very much appreciated. And I've got three tops, so this is the first one. Now, I have worked on one of these in the past when I was in the trade. I can't remember what it was. It might have just been a RAM swap or something back then. This followed the Sega. You got an SC1000, didn't you? And an SC3000. Those are like a home computer type thing. Although one of them, or both of them, might even be console-ish. But I think you could connect peripherals and stuff up. Those systems used a card, actually, a bit like the Hue card. Not got any of those to test, unfortunately. I have ordered an EverDrive, though, a cheap one from AliExpress, to get me up and going to test with this, because I've got no carts at the moment. So you've got a pause button, reset button. So yeah, you can. This is one of the only consoles out there that I'm aware of that's got a dedicated pause button. You know, you want to go and get a cup of tea, you can just hit pause and a reset, just like the Mega Drive has. You've got your latchable power switch there. Two control ports here. Now, I have got a Master System pad. It might be part 2 before I show you that, and actually there's a small repair of that as well, so that might be a video on its own. I did it ages ago. I just can't find what I've done with the pad. I know where the video footage is. Yeah, so two ports there, 9-pin, just the same as the Mega Drive. You can actually plug a Mega Drive controller in there, I think. We'll find out that later. And the only other things you've got here is an AV out. That looks like it's compatible with the Model 1 Mega Drive, so you can get RGB or composite out of there, I think. RF out, you know, modulator for your TV, and AC power adapter. From what I understand, that is the same polarity, and Mega Drive power supplies will work just the same. I think they probably used the same voltage and everything there, because that had 7805s in it, didn't it, the Mega Drive, a couple of them. So yeah, you can use a Mega Drive AC power adapter there. The only other thing that I wasn't aware of, there's a little flap here, just like you got on the side of the Mega Drive, look. And there's a breakout bit, can you see here? This is designed to be cut out, and there's a little edge connector. So I'm not sure what would plug into that. You know, I'm thinking about things like Mega CD, you know, maybe they had the idea of, you know, mounting something underneath, just like you did with a Mega CD. I don't know. I'm not aware of any peripherals that fit there, but post in the comments down below. I'm sure there's probably something you can connect up there. So I have to admit, I'm in love with this already. The style of it and everything, it's just so iconic, isn't it? It's just so 80s. I absolutely love it. I do love the Mark 1 design here. You know, it's quite a wide system, a bit like the Amstrad CPC, although not as wide. And obviously the CPC is a computer, not a console. But anyway, I'm going to echo the same point I made there. That the thing on the front here with this like block diagram, you know, it's like something technological about it, isn't there? As I said in that video, and you know, as I said in that video also, as a kid from the 80s, there was something super attractive about things like this. The marketing guys nailed it. They seriously nailed it with this, you know, technological, geeky sort of series of blocks that show nothing. They convey nothing. You know, it shows you a cartridge card, controller 1, 2, TV system. Yeah, that's the power indicator there, but you know, so it doesn't really convey any useful information. So yeah, it's powered by a Z80, probably running around 4 MHz. There's going to be some ROM and RAM on there. There's going to be VDP. But just like the Mega Drive, Sega, I think, nailed it with this console. You know, it came at a time where it was competing with things like the NES and the PC Engine. The spec of this is similar to the NES in many ways, but obviously it's got a Z80 and it runs faster. I think it's got a faster processor, like 4 MHz versus the slower speed of the 6502, but the 6502, I think, had some more efficiencies. But I think the Z80 had a 16-bit accumulator, so yeah, it kind of made the Z80 more powerful, generally. The sound on this, I think it outputs 3 square waves and a noise channel, so that's comparable to the NES. The graphics side of things, it's got, I'm trying to think how much RAM, I think there's 16K of VRAM, and it's addressed 16-bit, so it's similar in that respect to the PC Engine. You know, it's got 16-bit graphics, I guess you could say. And I think you can get 64 colours on screen at once, maybe not in all modes and things, but I think that's a thing. It might be 32 colours, I could be talking rubbish. So yeah, it was quite a nice spec'd machine, but yeah, come back to the nailed it point. Sega, you know, with a 16-bit system, the Mega Drive, there was loads of arcade ports that translated so very well to the Mega Drive, and it was a similar thing with this, I think. It's just my view. Some of those earlier arcade games, you know, before you got onto things like Golden Axe and Streets of Rage and stuff, you know, there's stuff before that. I mean, right, Streets of Rage wasn't an arcade game, but what I'm trying to get at is the earlier arcade games that targeted, you know, ports to this. They're fantastic. There's some really fantastic games for this. You know, things like Fantasy Zone. You could argue things like Space Harrier and Hang On were a bit limited, but they were targeting the later hardware. That was where the Mega Drive was a bit better aimed at it. But there are plenty of early titles and later titles for this that are just fantastic to play. I played Bonanza Brothers a fair bit, the Master System port, on the Mega Drive, and it's just such a good port, you know, considering it was running on 8-bit hardware. Please find enclosed the Master System stuff as discussed, some screws are sellotaped to one of the cases. I've also included a freebie for you to say thanks for your videos, I've learned so much. Master System 2s are RF only, that's interesting. So I've enclosed a 9-pin mini DIN and breakout board to go with it, that's fantastic, thank you very much for that, Martin. So yeah, no need to cut the case, RGB can tape directly to the video chip, or you can build an amp. Works perfectly with Mega Drive 2 SCART lead once modded. Thanks for the beautiful job you did with the A3000. He's talking about the Archimedes there that I did a trade for. And he said that in advance of receiving it, actually, so it's very nice of him to say that. It'll be one of the prides of my collection. Cheers, Martin. Thank you very much, Martin. But the top just comes off because the screws have been removed. Yeah, there's nothing taped in there. Now I'll show you the cartridge connector in a minute. There's a couple of pins misaligned. It's probably not the one that came off here, it came off another board. You can see it would have originally been riveted there, and obviously those have had to be cut, and the wings perhaps cut off the connector, which again I'll show you in a second. The board is not screwed in. It says they're bad. Now he did say one of these is kind of like you know, pulling the 5 volts to ground. And he didn't know where the short was, so we'll have a look at this one because I suspect this is the one. You can see the regulator's missing there, it would have had a 7805. You can see the VDP or whatever it is there, you know, that's the Master System, one of the Master System chips that makes the Master System the Master System. You saw that same chip on the Sega Megatech board recently when I was doing that repair. It was a 2-part repair, but it has this chip. Megatech has one of these to control the menu side for that arcade board. We've got a Z80 down here, so that's the main CPU, and then you're going to have a ROM maybe, yeah, that's a RAM. I looked up these in advance, that part number, because I thought that must be a RAM. There's a few of them here. It's actually XRAM, it's not DRAM, it's not SRAM, it's XRAM, which is SRAM in terms of its pinouts, but it's got DRAM inside there, and I think the refresh circuitry that you normally get with DRAM is built in, which is interesting. It's even got a pin for that. It can do an internal refresh, or you can externally refresh it. It's a bit strange. So how compatible those are with an SRAM as a replacement, I'm not sure. The pinout, as I say, is pretty much the same, apart from that refresh pin. So you probably could fit like a 6264 or something there. And obviously there's 3 of those. So you've got 8K of work RAM, that's going to be that, because it's nearest the processor here. I'm guessing that's the built-in ROM. Might be Hang On or something like that on this, I'm not sure. And then you've got 2 more RAMs here, so you've got 16K of VRAM, and I'm guessing that's the VRAM because it's right next to here, and I think, as I say, that's like the VDP. It's got the address decoder and stuff built in it as well. And I think it's got the sound built in, actually. Yeah, I think it has, because I don't see the sound IC, so the sound IC is built in there. Solder punks look pretty good there. It's a little bit dirty. Obviously we've got pads missing here where the 7805 has been taken off, and the pads where the cartridge slot are, yeah, they're not too bad. There's a bit of damage there. We'll clean that up, I think, first. So the card connections look okay. I think I'm just going to trim off these things here. Let's just do that now. Let's put this down, just because they serve no purpose. You know, they are rivets. Let's just see if we can cut into it. I'll have to do this a few times, just snip into it maybe. I think someone's probably tried to cut these already. Yeah, there you go. But it's going to take a few more snips before these are spherical enough to go through. Of course, you can just crimp towards them like that. See that, straightening it out a little bit. You can see they go right through like that, rivets. They're just going to be annoying if they're left there, and I'm going to cut my fingers on them probably. If you can adjust these so they're spherical enough, they should in theory just pull or push out. Yeah, I can feel it moving now. Maybe we can just now at this point, there you go, push it out like that, there we go, that's better. I'll do the same with that one. I'll report back. Right, that's both of the rivets out. Let's just try and unblock the odd hole here now, and then I'll clean up with IPA. We'll show you that connector, I think, next, and see if we can get that connector back together, because a couple of the pins are out of place on it. There we go, much better. I'm just going to put that up to the light, see if any holes need unblocking still. And yes, two need doing, this top one here and this bottom one here. Again, the thick rails. Right, that will do. Yeah, there's something there. Can you see that? It's like right over this trace here and right over this trace. It's like glue or something, I don't know, or epoxy, and I've just scratched it a little bit. So I'm just going to go over with the fiberglass pen here. We may expose a bit of the traces there, I don't know. Yeah, that's looking a bit more visible now. I'll use some magnification and just see if those traces are alright. Yeah, whatever that is, it's gone and it's not a problem. What's that on my hand there? I've got like black ink or something. I need to go and clean that off. I don't know where on earth that's come from. I must have touched something around here that's it's got that on. Anyway, if I test connectivity, where's it gone now? It's this one here. If we test down here, got a join, and we follow its fire, it goes up here, got a join, and there was the pin next to it here. So again, bottom pin, we got a join, follow its fire up, goes to there, got a join. So yeah, all of the connections on that side look good. So if we just flip that over, I'll just give this a clean. So this one here was barely hanging on the board, and it's come off, but it's just a ground. I was like, where's it connect to? Because there's no trace here. These ones all go down to this, so you can actually test those. You can buzz out from the top row here to this strip. If you've got a connection on every one, you know it's there. You know it works. Now the inner part of that, the via there for that, is still there. I can actually put the meter in there, measure from here to here, and we got short. And the reason being is that's ground. This one is ground, that one's ground. So once we've soldered the socket on, we could, if just to be sure, join a wire from here to here, just to make sure that it's got its two grounds correct. So looking at the connector that was removed there, can you see the end connections here? They've been pushed out of the slot, and of course as a consequence it's pushing that side up, same on both sides. And I think that's because there was obviously a piece of plastic extended around here with rivets, and those have been snapped off, so at the point where it's forced off there after being desoldered, it must have, the pressure must have just pushed these out. So I'm going to try and get those back in. I'll show you the end result in a minute. They don't look particularly straight here, but trust me, they are. That socket is really good. And like a lot of these connectors, the easy way to get them out is to push them through from the underside here. So you can see I've pushed that one out there. Get that back in, no worries. And we'll do the same with this one down here. So it's this one. What you've got to do is make sure the pin is flat, make sure there's no solder on it, grip it super tight, but like a millimetre or half a millimetre away from the plastic, and then push, and then move back a bit and go push, and just keep doing that. Push it like half a millimetre up. See, I just bent it there. I really need to do this with magnification. Hopefully that's focusing. You can see the contacts there, you know, the surface of this is fine. There's nothing wrong with it. Now, of course, I might need to bend these a bit. Let's just compare them to each other. No, they're about the same, those. So actually, with the additional bending that's probably been done to these, you know, that made them out of the channel there, when we come to slide these back in, if we get it right, it should be a nice springy connection. It literally is a case of feeding it down the channel. There, it's easier said than done. And once you get to this point here, before you push it all the way and you want to pull it back, so that it's within the gap there, if that makes sense, that's the hard bit. And of course you want to make sure when you feed it in, it goes down the little channel. And this is where I might need to just straighten this pin out a little bit. There we go, that one is back in. Perfect. So I'll just show you the technique here if I can. What you've got to do is, obviously, because this bit's straight here, you've got to get it to go straight into the slot. Hang on, I'm rotating it a bit there. And to the point where it feels like it's coming out the bottom here. Right, so you're on macro there. Now, the first thing, I can't see very well, I think we just need to just grip it and squeeze there just to straighten the flat bit. Yeah, that's not too bad. But you can see we just pushed it through to the point where there's a little bit of it there, but the key is to push it in so far, but not far enough whereby you can't just pull it backwards like this. Hang on. It's super hard to view this through the LCD. Can you see that? I just pushed it down a little bit, and now it's in its channel. And then, of course, you can just come here and pull. I forget which one it is now. It's gone in, look. That's it. And if you look at that, that looks fine. That looks absolutely fine. So that is now good enough to solder back on. I think what I might do is just plug a cart in here and then just measure connectivity from the traces to the connections, just to make sure it's good, but it looks good as new. There's nothing really wrong with that. So before I do anything with this, I am going to fit this again. Because I'm determined to try and get this working, even if it does need one or two of the custom chips replacing. So we'll try and get that on there. Is that going in? Yeah, it is, look. And push it into place. I'll flip it over, solder it so it's nice and flat. Just give it time to soak through to the other side. Press it from the other side nice and flat. I mean, there is a problem here in the fact that we've not got these rivets, you know. Those strengthen the slot here, you know, insert, remove. So over a period of time with lots of use, could get bad joints on here. That is a possibility. But I think the only way you're going to get one of those with the rivet things on it is if you take one from another board, actually. So before I even attempt to power this on, you can see I'm on continuity test here now. I've just buzzed this out. Pin 11 down here, I think it is. That's the VCC. Can you see that? 7.9 ohms. Sorry, 8 ohms. Now it's important I get a good connection here. I had 8.2 a minute ago. Yeah, 8 ohms. And we can test that up here where the regulator is as well, or missing from. Short there, look, 8 ohms. Hope you can see that. 7.9, maybe. Let's just go back over to pin 11 on the CPU. 8. So it's nearer to here than it is over there. Yeah, 7.9. So the fault is nearer to here. So it could be one of these caps, but it could also be the VDP or this RAM. Even the encoder. It's going to be something around here because the resistance is lower, nearer to where the regulator is. So I just did that same check over here. I think one of the pins here, I forget where it is, it's one of the in-between ones. 8 ohms over here, sorry, 8.1 ohms over here, 8 ohms. So it's something nearer to here. Now let me just show you. If I just move this cap down, I don't know if you can see, I think this has been recapped. There's a giant blob of solder there. So this cap could be the problem. I'm going to remove that next. But also this one down here, there's like a piece of wire coming out onto the trace. Let me just show you. So I'm going to remove this cap. Can you see here? I'm not even sure I can see it on macro now. There's a bit of wire here. It's pressed onto this trace. Is this one of the power? It probably is. Look how thick it is. That might be the issue. So I'm going to remove this cap and remove that cap and see if the short goes away. Of course that diode springs to mind. I better check that, but I think that's reverse polarity probably. And you can see these have been tinkered with here, so I don't know, maybe it's a recap gone wrong. Good God, that's like touching concrete. See, that's not melting at all. Good God. I think I need to get the a larger tip on there, or use the desolder station for this bit. Anyway, let's just give it a go. Do it in a few passes, perhaps. Right, let's have a go with the desolder station. It's the only way I'm going to get that enough temperature there. Look. Can't get onto that leg there. Right, let's try and pull it while I heat now, because the solder is not completely freeing up there. That's one turn. Right, so it's none of those around there. Just measuring around further, so if I show one of these caps here, I'll tell you what it says, 7.8 ohms. This one down here, this XRAM, 7.9 ohms. The one over here, now look, it's a different colour. Can you see? This is like shiny, yeah? This one here. Now, it shows 7.9 ohms, but sometimes you put it on here, it shows 2 or 3 ohms. It was doing a minute ago anyway. It's not doing now. That's weird. Maybe it isn't that, but you can see a difference here. Can you see, like, the silk screen's very visible here? It's not. It's like this has got super hot, maybe. I'm suspecting the regulator's short on this at some point, and one of these RAMs here, possibly this one, saved the board. So from a quick test, I know what the problem is with this already, and well, you'll see. So pointing you at the Agilent here, this came from Ian Scott Johnson. I'll post a link down to his channel below. I'm going to mention this lots of times in future, and his channel is a fantastic guy. He's an amazing electronic engineer. He makes some precision kit himself for measuring super low resistances and currents and things. I think he does. I could be wrong. Yeah, trust me, I do watch his channel. I love his videos. So anyway, check out his channel. If we just go up on voltage here to 5 volts, yeah, over to current. We don't want 5 amps, we want 1 amp limit there. Started at half an amp and I couldn't work it out. And the voltage dropped down to 1 volt, but you'll see if I switch output on, see we've got a voltage drop there. It is drawing an amp. It's in constant current, and feeling here, yeah, that chip there is getting very hot. It's getting hotter, ow, yeah. Everything else is cold. Oh, hang on, that one's getting hot as well. Ow, that one's hot. We've got 2, I've switched the output off, we've got 2 bad RAM chips, not just 1, but 2. It's interesting how both of these RAMs have failed here, so that one, yeah, that one and that one. So I need to remove those, and we need to get 2 replacement RAMs, but if those have failed, regulator's missing. Hang on, cat's pressing the buttons on that, can you hear it clicking? Let's switch it off. Yeah, if the RAMs have failed, the fact that regulators are missing, what's probably happened is the regulators failed, it's shorted more than 5 volts, you know, i.e. 9, 10, 11, 12, that's the sort of voltage you get on the power supply that feeds these, the DC input, and it just so happens that those RAM chips have failed and perhaps saved the other chips, but you never know, something else could have failed on here as well. But anyway, we'll desolder those, get some sockets on. I'm going to see if I've got any spares that might be suitable. As I mentioned earlier, these are XRAMs. Now I've got some 6264s, which I think should work here, 8K, 8-bit. Pinouts look almost the same. I think those should be alright. And I did look at some of the 6264s, and they seem to have 2 chip selects, but that might not be an issue. One of those chip selects is probably just another address bit, effectively. And now the address bits are different, the order, but that doesn't matter. It's just RAM. It doesn't matter about the order of the address bits. The address bits could be any old way you want, really, as long as the pins are, you know, the actual positions for the pins are correct in terms of you've got an address bit on a certain pin. It should be alright. That's probably not making sense there. I'll show you what I mean with a couple of images side by side in a minute, show you how the pinouts can vary between the substitutes I was looking at. And you can see the way I was powering that there's just, I did a connectivity test from the positive there to this first pin, which is where the 5 volts comes out of that regulator. And the ground was just on one of the, you know, the bits of ground around the edge here. So I got the first one off, I'll show you the second one. So I put some little red marks here, I can wipe those off later. So I'm going to start with the bottom row here, and the corner pins, I think, yeah, this one here is going to be a ground or VCC. So this is going to be the hardest one by far. I'm trying to see where it's bent over. It's bent right over this way, I think. So first of all I need to get under it, straighten it like that. Hold on there because that one's absorbing lots of heat. If you move the iron, you see the pin moving. There you go, you can feel it moving, you know you're at temperature. So that might need a bit more work, that corner pin. Of course the desolder station makes light work of this. But anyway, look, do the next one, it's wobbling. Let's give that another go. And I'll just work my way along. So I've desoldered those pins there. Might need to give 1 or 2 of them another pass. We'll just have a bit of a pivot here and hopefully some of these will detach. They don't feel very loose, these do. You can hear them snapping off there. Yeah, one side's nice and free, the other side isn't. Of course, I could just cut these chips off. I'm pretty sure they are baked because they get super hot. They shouldn't get super hot, just with 5 volts going through them. They're on different buses as well, so it's not like processor could be causing that. And of course the processor and everything else on there is cold. Anyway, I'll just need to just focus on the pins that need a little bit more work. Inspect from the other side as well. So that should be it. I've pressed into each one here and I can see them moving away from the pads. That pin there is a bit tight, but it's free. Each one of them I can feel it, just the pin just wobbles up and down. And it's the same on the ones there as well, so let's just try and get a little bit of leverage here. Just gently. If it's ready, it will just come up. You can see here, that side's up. But it's this pin here that's potentially, there you go, it's coming up. Swap to the other side, just try and get under there if we can. There we go, that's coming up. It's annoying because these are in the way. If you put leverage on those, you'll break them. You can put the flat part there, look. Yeah, it's coming up, look. Just got to hope they are all free. Have we lost a pad? We made them. No pads missing. No through hole. So that's both of those off. So I did those both exactly the same way. You can see there's no damage there and there's no damage there. So I'll clean around with cotton buds, get a couple of sockets on, and then go and raid my spares to see if I've got anything suitable. So they're quite cheap, these sockets. They've not got the strut in the middle there. I could have put turn pin on it, but where's pin 1? Pin 1's around that way. So the pin 1 marking is that circle there. There's a 1 as well. I can't really see what I'm doing. It's that time of the day where it's going dark. There we go. After a bit of messing and unblocking a couple of the holes a few times there, just to widen them, we've got it on. Just need to solder it now, and then get that final one on. So it's on constant voltage now. I am not sure how I got constant current mode before. It's a really weird way of doing it on here. But nevertheless, you can see I've got 5 volts and just less than 400 milliamps. And I'm going to use the light from my phone here, but you can see we've not got round fit at the moment. So I'm going to go and find what I think might work with this, some 6.2, 6.4s, and then we'll try it with that. So as you can see, I had to remove this chip because this was also getting hot. Now, the situation we're in now, it's drawing a very low amount of current, nothing's getting hot. I've got an alternative chip here. I'm not even sure that would work, but it should do, I think. Yeah, so nothing's getting hot. It's only drawing 140-ish milliamps there. It's on constant voltage, actually. I need to work out, I still haven't worked it out really, how you put it on constant current. I had it on constant current at the start. I can't get it back on constant current again. It's really quirky the way it works. Anyway, I'll cover that in the video for that. So, logic probe connected. This board is kind of beyond, actually. So the CPU clock comes out on this corner pin on the VDP here. Can you see that? It's just stuck high. We've got no CPU clock. Now you can see I've got a 50 megahertz crystal there at the moment, just temporary to rule out the crystal, but actually it's not that, so I'm going to put the old crystal back on. And I've had the scope on this as well, but anyway, I'll just count along here. So pin 6, pin 1's down here, 1, 2, 3, 4, 5, 6. That again is the clock, yeah? So you can measure from there to that corner pin on the VDP I showed you, get dead short, and it's just stuck high. So there's no CPU clock, so that's the first problem. Now the reset on these is a bit of an odd one actually. I forget exactly where it goes now. It's this diode here, yeah, this resistor and this cap, I think, and ultimately it goes to, I think, one of the pins somewhere on here, I think, and then the reset button goes to a pin over here, I think. Is it that one? I could be wrong. That might be the clock actually. Let's just probe there. So the reset switch goes there. Can you see that? That's toggling between low and high. So it's got like a soft reset, it goes to a different pin. The resistor capacitor diode here, the timing bit, goes to another pin on there. But in any case, if I look at the reset, so looking at the pin out here, reset on the Z80 is pin 26. We've got the same problem actually, so it goes, you know, it's 20 pins, pin 1's here, that's pin 20. So we just need to go 6 pins over here, so 1, 2, 3, 4, 5, 6. See that? That's high. So actually it's come out of reset, that, hasn't it? 1, 2, 3, 4, 5, 6. Yeah, so the Z80's come out of reset. Well, we think it has. But if I press that reset button, there's no change there. So the reset's not going through the VDP to here. That's just kind of stuck high. And again, like I say, nothing's getting hot. Only 140 milliamps being drawn. So one thought I had is maybe you need the RAM here for the VDP to be able to process. Now the PPU on the NES just does video, but this does more than video. I'm wondering if it's using a couple of bytes or something of this RAM here as like some, you know, to hold state of doing something it does. I don't know. That's the only thought I had, because it's not getting hot. But then again, these were nuclear in terms of temperature. It stands to reason that maybe something died here, because what you've got to remember is when there was more than 5 volts fed in through the regulator that failed here, it might not necessarily have been the RAM that failed first. That could have been the last thing to fail. Something else like this is nearer to the regulator here. This could have died. Could have also killed this ASIC here as well. Now you can't get spares. Well, correction, I saw one of these on AliExpress. A seller's got 1,000 of them apparently. So I don't know whether they're genuine. The label on the top looks a bit weird. It doesn't say Sega, but it has got the right part number. So I might just take a gamble and order one of those. But I think in the meantime, I'm waiting for RAM. We consider ordering one of those. We can't do anything else with this at the moment. I've exhausted all options as things stand. We know we've got no CPU clock coming out of here. It's just a question of, does it need the RAM? I don't think so. I don't think so at all. I'd expect that clock to be there regardless of it coming out of reset, to be honest. So yeah, I think that. We'll move on to the other board. Now the other board has got a number of faults. It might be a case of we remove some chips from here, take the chips off the other board and fit them onto here to get this board up and running. You know, start with maybe the VDP, because the other board does output video, but it's you know, it's not booting carts and stuff, as you'll see. So let's have a look at this one. Now you can see here someone's removed the mask ROM. This would have been a game, I think, you know, like Hang On or something. I look at the traces here. It's yeah, a little bit bodgy. You know, got some damaged traces. Got a quite thick wire there, fixing that. There's been a bit of tinkering with the Z80 here. Look as well. We have a fixed wire here on this trace going to the card slot. These have a card slot, the earlier ones. So it not only takes cartridges, but you can put the, is it an SC 1000 or SC 3000? I forget. Yeah, cards, a bit like U cards, plug into there. Everything else on here kind of looks okay. You know, if I look on the underside. Yeah, I don't see much rework there other than the thing we're already aware of, the ROM there. So, yeah, this one outputs video. I'll show you that. We'll connect it up via RF. We'll just see if we can power it on. I might even try a cart in there. You know, in theory, we could just borrow the ROM from that other one, stick it on here, fix this. Maybe it'll then work, but apparently the problem with this board is it wasn't booting all carts and things, and this is why the slots were being swapped around, you know. Someone originally took this off and took this from the other board. Now you can see the rivets are hanging through there again, look, so those may need cutting off. Oh, we've got another fix there, look. Yeah, so there's obviously a damaged trace. Look, and that pin there is kind of squished. So at the very least I would probably desolder that pin or the entire socket and pull that out and fix that. Remove the rivets again. Certainly remove this stuff here and then clean up, fix with very fine wire, not thick wire like that, and get a socket on and get a ROM or something in there. But I think there's something else wrong with this, because I suspect this one's not working either, but it is giving video. So the Agilent set to output off. We'll connect onto the positive of that cap connection there, and we can just connect the black to anywhere on the ground here, actually. Just get a nice grippy connection there. And if we switch it on, you can see normally about 0.4 of an amp there. That's about right. Now we've got a black screen. Let's switch the output off, switch it back on again. Yeah, it's no surprise we're getting a black screen because we haven't got the onboard ROM, so it's not going to work without that. We can try the EverDrive here. Let's power it off and plug this in. Right, so it's off. Just carefully try and line that up and switch it on. Yeah, and nada, nothing. Let's just take it out, put it back in again. There is a chance that obviously something connectivity wise there means that the slot's not going to work. You saw a line there, like it was doing something, look. I don't think you saw that, it's like a line in the middle. And of course this one could just have bad RAM. It really could be. That simple. Let's press reset. No, nothing. We can compare, if we have a look at the clock, let's just switch this back on again, and let's just check that's working. It is. And let's just count along here. 1, 2, okay, that's pulsing. 3, 4, 5, 6. Yeah, so we've got a clock. Let me just test the reset. So the reset was 6 from the left, wasn't it? Yeah, that's not resetting actually. Got the same problem, haven't we? Yeah, got exactly the same problem. So the reset would appear to be like a soft reset, whereas it's not actually doing a hard reset on the processor there. So I guess what we can do is take what we learned from the other one. When we put that socket back onto the other one, I know that the connections here, I think, go to here. I forget which one it is now, which side. Hang on, have we got a problem there straight away? No, we don't. Yeah, so we can just test along here like this. If you step along, you'll work out if you've got short between them, because I'll show you on the underside of this connector, but all of the copper's been worn off the traces when it's been desoldered, so it'd be very easy to bridge two together. So by stepping along, you know, starting there on the first pin, yeah, we've got a join, then stepping to the next one. If you had a join there, you know you've got a short, but then we can just step our way along like this and see if everything's joined up. Yeah, that socket is really dirty actually. The solder points, yeah, alright, they look a bit questionable there, but I don't think that's the issue. So I think we'll shift our attention over here. I'm just going to get some flux on here and use a bit of braid just to clean up the 4 or so pins there, because they look a little bit shorty. And I'm going to remove this. We'll get some flux on here. We'll tin over this stuff and just work out what's actually borked around there. We've even got a pad missing there, that might be the issue. And let's just, I don't know, touch this to start, get rid of that wire. There's a wire on there, look. Oh god, what a nightmare. It's like a resistor like that, it's too thick. You want something nice and thin. So we'll have a slide along here. It's just going to tin anything that's affected. Oh, this braid is too wide. If you're using wide braid like this, you need obviously a wide tip. There we go, it's coming off, I think. There we go. Right, let's clean with some IPA there. You can see I've just tinned those traces there a little low. So there are 3 or 4 traces there that are borked actually, which makes me wonder if that's the problem, because we only had 1 fixed wire. There's more than 1 trace missing there. Yeah, and you can see that now zoomed in. You can see we've got a wire and a trace coming here that's cut off, and then we've got a trace in the middle there that's not going anywhere, and then this one here kind of looks like it's maybe not joined properly. So there's 3, at least 3 missing connections there. I'm not finished here because we're going to redo the 1 wire here anyway, because we're going to have a socket on it. But yeah, I've joined the 2 connections up there. Might not be able to see from there. Now the pad that's missing here, I've just checked, it just goes to the chip. It's not like it comes down here to the pad and then through the via to somewhere else via that via. It doesn't. And it's the same with that one there. That one's missing. It comes from underneath this chip here to that pad, doesn't go through and then out elsewhere on the underside. So in theory that should be okay. So the final thing now is just use a little bit of braid and just mop up the excess here. I don't think this really needs doing, but there is a bit of solder there, isn't there? 1 or 2 of these pins here just look a bit questionable. I did notice that the gate array looks like it's been off here actually. There's huge blobs of solder. You might be able to see some of them here. Yeah, it looks pretty blobby there. So yeah, anyway, that looks a tiny bit better. So something interesting I read, and it was something I was thinking about, is how does it switch between the ROM that's built in and the slot? And you know what, it's pretty obvious. There's obviously going to be something on this ROM here. The first 8K contains like the BIOS, if you like, just a little bit of code that boots initially, and maybe checks whether there's a game in here, and can switch, because I'm looking at the pin out of this, there's 2, or is it there? I forgot which one it is. One of them provides 2 chip selects, you know, one for this or one for the cards. There's no way that that could be actually automated, I think. You'd need on a BIOS, and that's what that 8K is for. So that would explain why this is not booting with the game at the moment. So I think we need to get a socket on there, maybe pull that chip off the other board, and try it in here. There's going to be a lot of to and fro going on here because of the state of both boards. You know, the other board has been nuked with overvoltage. Potentially everything on that other board's faulty. We know the VDP is on that one. So I'm not sure where we're going to end up. Which board are we going to end up repairing, and which board are we going to end up stripping for spares? I will order one of those. I might even order two. Maybe we can get them both working. I honestly do not know at this stage. Anyway, let's go get a socket on there. I thought I'd show you those fixes there. So we've got one that comes down here, and I can't even see them actually, even on macro here. Yeah, anyway, you can see there's two wires. I think one comes down here. Yeah, this is the one. See, the pad's missing. Let's just add a tiny bit of solder back to that one there because we removed a little bit. Let's just see if that's going to come up. Still looks like there's a fair bit of solder there despite using the desolder station. There we go, it's coming up, look. Let's just try under there. Hopefully won't lose any pads here. There we go, it's coming off. There we are. No worries. So, it's off that board, isn't it? Got some fluff under there. I might remove the VDP from this one in a bit. Anyway, let's focus on what we're trying to do now, which is try and get the other board up and running. So let's just see if this will just plug straight in. I'm just going to just squash these down and straighten them a little bit. One or two of these may need a little twist, I don't know, they don't look perfectly straight, do they? So it was exactly the same after that. Now obviously, you know, this one's giving video and stuff. We get an RGB, we're getting a clock, we're getting a reset. Everything looks normal, so it's anybody's guess as to where the fault is. This is where you need some diagnostic software to test the RAM and test things out, but yeah, nothing runs on it. The only other thing obviously is someone's soldered awful soldering around here, as you can see. So maybe we need to take that off and swap that, but we don't know whether the one on the other board's any good, do we? I think the next thing I'm going to do is remove this. I might then remove that and socket those up. It's useful having these things socketed because I can then swap the things between the boards, but the ROM, I couldn't identify it using ROM idents, but what I did is I dumped it and I scanned right to the end of the file. I could see Sega at the end of it, and I scrolled a bit further up and I saw some text that said like left select track or something like that. Something that made me think, hang on, is on there actually. So I think it's actually readable. If you had a problem with a bit or an address or something, that probably wouldn't get readable text. So I then compared to some other SMS BIOS ROMs. I couldn't find exactly the same one, but I see the same sort of thing in there. So right at the start, the code at the start looks very similar, if not identical, because there's an 8K, as I mentioned earlier, I think that it uses to bootstrap from to, you know, work out what you want to do. So I think the ROM is actually okay off that over voltaged board, so it's got to be either one of these or one of these. I hope it isn't one of these because it's going to be a complete fail, isn't it, until I can get a spare. Anyway, I'm going to get that off. The interesting thing with that RAM is there's like a trace of solder points underneath, so although that RAM doesn't look like it's been replaced, maybe it has at some point. Maybe it had the thinner type of RAM on there in the past. Maybe someone's just fitted bad RAM, I don't know. This is one of the consequences of working on a board that has been worked on. I hate it. I seriously hate it when someone's been there before you and done random stuff. And if you do replace chips, fit sockets. Never solder the chip straight on. I mean, you never know, there could be damage under here. If it had that strip there originally, and, well, the pins look to be still there, don't they, for one thing? That's blooming strange. Because it does accommodate the thin ones, or the fat ones like are fitted at the moment. In this place, the other spots don't. This one does, though. But I think that was done by a different person that did the other things to this board, because the solder points, they look factory. They look very different to the other soldering. And I'm not being critical of either soldering here, really. They just look different, look like they've been done by a different person. Of course, I now need to detach my wire, don't I? If I can get it off. There we go. Can have that back up in a sec. Yeah, that's just lifted off on one side already. It's just this bottom side here that isn't quite there. Let's try and get it off now. It's just... There we go, it's coming up. There we are. No damage. It's weird, that line in the middle there though. Look, those look like pins, can you see that? Those look like pins, like someone's chopped them off. But then here, they're totally flat and smooth, like factory. Maybe it had that type of chip on it at factory and they chopped it off and just left the pins in. Blooming strange though, it really is. Anyway, so we've got our chip out. Let's get a socket on. Again, we have another socket on there now, so let's get that on. SLR Mod Shop made me laugh in Discord. He was like, I've worked on loads of these SMSs, they're usually alright, you don't get any bad chips on them. Well, so far these two are completely borked. Absolutely everything on them seems to be broken, doesn't it? I think this one not. I think the VDP on this one's possibly be alright. I'm reluctant to say is alright, because obviously it's not working at this moment, is it? And this is the thing, when you've got customs like this, if you do not understand with an intricate detail how the system works, you can probe things till the cows come home and make no progress. You know, we know we've got a clock, we know we've got a reset, we've got data bus and address bus activity, we've got no floating connections on the things that look questionable, there are no breaks in traces as far as I can see now, yet it still doesn't boot. So you're left, you know, no temperature issues on this one, so you're left wondering, what on earth could it possibly be? It turns into guesswork. Yeah, you could start scoping signals, but I don't think that would reveal anything. I think the issue on here, hopefully might be the RAM. If it's not this, it's going to be perhaps the Z80. You can see where I'm going with this, can't you? If it's not that, it's perhaps the VDP. And if it's not that, it's going to be the ASIC. Right, we've got the BIOS back on that I think is good, just based on the fact I can see Sega in the text. And I've got my dodgy Sony RAM there. I think that's like twice as big as it should be, so is it going to work? I don't know. I've been putting the current down to 800 milliamps, actually. You could probably go lower. And switch it on. And a black screen again. Oh, great. Ah, wow, it works. Haha, fantastic! Sorted, so it was that RAM. That was the issue with this board. Now, obviously, we've not got a cartridge in, but this is the on-board cartridge. And, yeah, hang on. I suspected I'd hang on. But then I read something about this Safari thing, Safari Hunt, this combination thing that's on there. Point light phaser gun at the screen. Well, I haven't got a light gun thing. I'm trying to work out where my joystick... hang on. I tell you what, I'll plug in a Mega Drive controller, because this is the next thing. Are the ports going to work? And... press the button, see. Don't know what that does. And it's not working again, is it? Have we got another problem with this? Yeah. So, I don't know. I don't know. There is another problem with this. It's not just the RAM, is it? Of course, that ROM chip could still be a little bit borked. That is possible. No, it's not doing anything now. Switch the power off and on. Oh god, I hate problems like this. So there is something else here. It takes ages to come on, is that normal? No, look, you see, it's doing a boot loop, look. It's doing some sort of boot loop. I wonder if we've got a questionable Z80 here, actually. It's lukewarm, the Z80. Let's power cycle it again. And of course, it could be that ROM. Maybe that ROM was damaged by the... power thing on the other board. No, I can't get it back up now. I'll let it cool down a minute and we'll try it with a game in here, just in case the EverDrive will boot. I mean, one of the things with this is it doesn't come up with a Sega thing, does it? And then look, we're getting a boot loop, look. I think my celebration was too soon, actually. Now, of course, it could also be, let me just power this off, it could also be this RAM, Because if I've got a floating bit there somewhere, maybe there's a chance it could have booted that first time and now it's playing up because one of the bits there is floating. We can probe that, I guess. Let's switch it on. Let's just have a little probe around. I think I'm more inclined to think it's got a glitchy Z80 on it now. Oh, that's flowing, look. What's that? So, hang on. 1, 2, 3. So it's 24. Yeah, pin 24 is floating. I'm going to go and look that pin up. Yeah, I think one of the address pins is not joined up here, actually. If I just connect that back in there, that's right. Power it on. Maybe something's intermittent here, because that pin, 1, 2, 3, 4, 5, 6. Oh, the menu's come back up again. It's pulsing. A minute ago, that was off. Yeah? So maybe we've got a flaky address bit, but it's back on the screen again. Now, that could be a consequence of this cooling down. Right, I'm going to take a guess and say Z80. I'm going to socket that up next. Oh my god, I'm losing the will to live on this board. It is not the Z80. It's exactly the same. So when it's been on for a few minutes, this is what you get. You just get a black screen. Oh, hang on. Eventually, sometimes it comes up, but then you press the select button, and then it bombs. Oh, it just goes back, look. You see, look, it started to load, hang on there. Maybe it's a VDP problem, maybe the actual RAM for the VRAM's bad, maybe it's something in there. I don't know, let's press the reset button. But you see, look, the reset button doesn't do anything, I don't get it. Don't get it. Right, I think I know what possibly the final problem is, but there might be another problem with this yet. Going back to that pin, do you remember there was a pin where it was high impedance? I dismissed it and then went on and swapped the CPU. Could have saved myself a CPU swap, but you know what? It's useful having that socketed because this board could have lots wrong with it. We might have to take that off and test it on here when we get this one up and running. Anyway, so I'll show you what it is. It was the 5th pin. 1, 2, 3, 4, 5. So this is the one that doesn't work, but it's, the traces are alright. And then I figured it should be in line with the chip above, and it is. Yeah, and then it's going to join somewhere to the CPU. Yeah, there we go. And if we test on this one, 1, 2, 3, 4, 5. Now bear in mind it's intermittent. Look, it's not joined. It's not joined. So that's what it is. So I need a wire from the 5th one here to the 5th one there, and then we'll retest it. Right, now it works, and think about it, it's obvious there's a pattern here. When I first switched it on, all we saw was a black screen for ages. Watch what happens now. We see Sega. What that tells me is it was an address line. The addressing was wrong there because of that, and it was jumping further into the ROM, and then perhaps it was rebooting or going round in a loop. I don't know, somehow it was recovering, but nevertheless that's now consistently showing the Sega thing. Not hearing any sound. That could be the next issue. So let's hit the fire button. Hang on, I need to plug the joystick back in again. Oh look, hang on, it's loaded. Oh yes, fantastic. One down. No sound though. Oh yeah, there is, it's very quiet. It might have tuned in very well, let's turn it up. Yeah, you can hear that. I'm in low gear here. Yeah, I am. Oh, you got 3 gears, I didn't know you had 3. Sweet! So, got a lot of work to do on that other board, haven't we? There is a bit of egg on my face, the CPU. As soon as I saw that high impedance connection, I really should have dealt with it before considering swapping the CPU. It's nice to have that socket on there though, I think we'll probably need it, yeah. So yeah, bad RAM and bad traces and things, and obviously I had the missing ROM. So this is the ROM from the toasted one. At least something survived on that board. So at the very least I've been able to get 1 out of the 2. So that's it for part 1. There's quite a lot more in part 2. Obviously waiting for a VDP. You can see I've removed the VDP from there. That's covered on the next part as well. And I can show you the other shells and things here. So this is the one I showed right at the start. And this is another spare one here. There are some corroded screws and stuff on the underside of this, but you can see this one's still got the plastic. That's quite cool. And then we got this one. And finally the Master System 2 that Martin kindly threw in. So yeah, it's a bit beaten up, but yeah, we'll cover that in a video on its own, I think. I may do the RGB mod to that, swap the modulator out for the DIN there, but so yeah, this does work, but I will do a video on that. So I do hope you found the video interesting. Massive thanks to Martin for sending these. If you would like to support the continuation of the channel, please see the Ko-fi and Patreon links down below. Just $1 makes a huge difference. Special thanks to all of my patrons and people on Discord that support me. Much appreciated. Thanks for watching. Catch you in the next video.